Greetings, folks. Steve here.
And Matt.
And tonight we are working on getting the Lexus ready to start. So we have quite a list of things we need to get done today. We have, it's all wiring stuff, okay? So we have the engine harness is made and good, and I'm pretty happy with how that all went.
Oh, looks great.
But there's a lot more to do. So I have here just a list of things. I've just been brainstorming all week of all the wiring we have to do. And each one of these is an item that needs either power supplied to it or ground supplied to it. So there's actually kind of a lot that goes into redoing an entire engine harness. Engine harnesses have a lot of circuitry going on within the engine's harness itself, such as splices where maybe one power supply branches off to several different things. For example, the coils have their own power supply that comes from a single wire, so then you have a splice that breaks up and sends power to them. The injectors are the same thing. They have power coming from a single circuit that branches off and goes to each of them. So when you go and redo the harness, you have to still find a supply for powers of that sort. And you still want them to be ignition voltage. You don't want them to be energized at all times. What? Did that just break while you were... How did that happen?
I don't know, look how frayed it is, though.
Ooh, that looked like it was like chewed up.
Yeah.
Damn, that sucks. Was that the good one or the one we didn't like so much?
No, this is nothing. This is not anything we're using. I just noticed it, and I was thinking if we need to cap it off for some reason.
Oh, we better see if it's got voltage on it. Yeah, so apparently there's some wiring that was just kind of chewed up or gnawed up there. So Matt's working on getting the circuits liberated from the harness that want supplied power to the main engine harness connector so that we can once again hook them up to our bulkhead connector and still use the same circuits, or hopefully the same circuits, ideally, to supply power to our stuff. So that way diagnosis in the future will be easy. We know what fuse does what. Everything is still copacetic. In addition to power supply, there's a lot of other things that you may not really consider that we have to consider at this point. The starter signal, that circuit went through the harness and went into the engine harness and down to the starter. Well, now that's not there. So we have to run another starter signal. It still has to come, obviously, from the ignition switch. The alternator wiring, on this vehicle, the alternator is controlled or commanded by the ECM. And since we're not using the stock ECM anymore, we have to find a way to basically keep the alternator working independent of what the ECM is doing, which is nothing, obviously. So we had to run a wire for that, and then we have to find that circuit. It really just needs a fused 12-volt source for the alternator. What else was weird? Oh, the park neutral switch. The engine harness used to go down to the transmission, to the range switch, so that park neutral switch will inhibit the starter from ever cranking. Anyway, so all these things have to be sorted out. We have an oil pressure switch on the IS300. The oil pressure switch is an input to the ECM. The ECM sends a message to the instrument panel cluster for your oil pressure light. So we're not going to have that anymore. So we're going to be just utilizing a unique solution for that also. So we're working all that out right now. I'm getting the ignition control module wired in, and Matt's looking at me like there's a lot of broken wires there.
At least two.
Are they like pulling apart while you're messing with it?
This has voltage on it.
How much?
Nah, just 1.5 volts with key on.
What the dude? So these wires.
So these are the two that were broken off. This, I don't know where this came from. This is buried in here somewhere.
So you're just trying to wiggle out that one wire. Are you like, do you think the wire you're pulling on is like severing them?
No, I haven't pulled on any wires. I've been pushing it through.
Oh, I'll just keep on going.
I'm gonna have to butt connect these together. They got voltage.
Do you have the ignition on right now?
Yeah.
Okay. Yeah. Anything that has voltage on it, we need to.
I just turned it off.
We need to wrap or do something to.
Look. That's frayed up right there.
What's going on right there, dude? This was all totally wrapped.
That's frayed up right there. It's all right here in this.
You don't think that happened when you were cutting it? It had to have.
No, dude, look at it. It's all chewed up.
Oh,
it's not a cut. Yeah.
What the hell? Well, whatever. I guess if we have any weird electrical gremlins, we know where to start looking.
It is, yeah.
So anyway, that's on the docket today. We got to do a quick oil change on it. So right now we're just chipping away at wiring. So should be getting this thing started up here in a couple hours. I doubt we get much chance to really drive it today, but really we just want to make sure everything's working right. We have to reset our timing offset. Obviously, we're not going to forget to do that again. or we're not going to forget to do it right again. So yeah, just working away at kind of some of the unpleasant, annoying, tedious part of this kind of build, but it's coming along. All right, we got Matt in here working on our oil pressure light. What you got going on here?
Well, so since the original oil pressure sensor runs through the ECM to the dash, we are not going to be able to use that for our oil pressure sensor light. So we're just going to install this little green guy, and when it's got good oil pressure, he'll be lit up. And so we're just putting it somewhere nice and visible right here by the AFR gauge. So just a little hole in the plastic, and we're going to just wire it up from there underneath the dash. And basically, whenever the engine detects correct oil pressure through the oil pressure sensor, it's going to ground this little light, and it's going to turn the light on. And so anytime that the light is on, we know that we have sufficient oil pressure to run the car.
Cool.
And if it cuts off, we know something's wrong, and we need to turn it off right away.
Yeah, and the problem in most cases, most likely, is just going to be the $6 bulb that we use to detect oil pressure.
But better safe than sorry.
At least then we know.
They sent us 2 though, so
They accidentally sent us 2 for some reason.
So we'll have one to test to make sure that the bulb's not just out.
So he's working on a voltage supply for that light, as well as a place to mount it up. And then the ground control circuit's going to come through the bulkhead to our bulkhead connector, and then go to the switch. So that's simple enough. I have been working on the ignition control module wiring here. 3 of those wires go to the mega squirt, 3 of those wires go to the bulkhead connector to the coil, and that's all done. Now I'm working on voltage supply for the coils and the injectors and all the modules. So we are going to have a knock module that needs power, we have an ignition control module that needs power, and our coils need power, and all those 3 items are going to come from the same power source, which we sourced through the stock harness coming from the existing fuse block. So the injectors are getting voltage from a different circuit, so they'll be totally separate. And finally, I'm working on a power source for the ECM, which is coming from the same circuit that supplies power to the stock ECM. So it'll be all alone, it won't have any noisy devices messing with its voltage signal. And I just wanted to touch real quick on the way that I'm mending wires together. So I have been party to endless debates about whether crimping or soldering is superior, and I've kind of experimented with all methods during my career. For the longest time, I preferred soldering, and what I would do is I would solder wires end to end, give them a good twist, hit them with some solder, slide the heat shrink tube over, and tighten them up. And I do think that that's a very effective means in butt connecting 2 wires together. It's very reliable, it's very strong. The soldered joint won't fail. I've gotten in a lot of arguments about this. One of the crappiest things about car culture, or about just the community and what we're doing, is everyone just has an opinion, and they all want to tell you there's only one way to do things, and it's this way, or you're wrong, or you're stupid, or if you didn't spend all the money on the high end, whatever. That's all bullshit. And a lot of what we do here at Master of Machines is we prove that there are other methods to get the job done just the same. On the Z, the entire powertrain management system wiring is done end-to-end, soldered joint, heat shrink tube. That's every wire in the Z is done that way with the stock wiring harness that was on the engine when we got it. So basically, I just tapped in at where the stock ECM location is to the mega squirt. I chopped those connectors off, soldered them to the mega squirt, pigtail, done. It's been great. That said, an end-to-end solder joint or an end-to-end crimp joint both have the same folly. They both have the same flaw, which is that it's not the joint that actually fails. What it is the wire directly next to the joint on either side. So what you have is a hard, stiff section where the joint is, and if you are doing this to this mend, if you're mending these wires in an area that has a lot of movement, then you have a hard corner that's just bending right at the edge of the joint. So solder joints and crimp joints are prone to fail in that circumstance, and that's just the way it is. In motorsports communities, it's condemned to do that type of wiring repair, although I have done it dozens of times, and stationary wiring without issue. So what I've since adapted to, and what I've been using recently, and what we're using on the Lexus, anywhere that we can't have a full wire, end to end, connector to connector, crimped on pin, basically anywhere that we can't just run a complete wire, the way that we are mending the wires is through, it's a technique that I learned actually through a Ford service bulletin, where you actually do a crimp side to side. So for example, let me show you the joint I'm working on right now. So we're gonna have our 2 circuits running parallel, and of course peel the insulation off the tip and twist them together. And from there, we're going to be splicing using one of these little lugs, little splice lugs. It's basically just a little brass, focus. Basically just a little brass V-shaped lug. And we're gonna load it into our crimping pliers as we see here. All right, so we're gonna grab our wires, we're gonna crimp, they're gonna get stuck. They always do. All right, and now we have the 2 wires crimped together. But of course it's kind of awkward, you know, to have this little T sticking up on the end. And the last thing we want to do is bend a hard elbow right at that crimp, because that's where they fail. So first thing I'm gonna do is trim off this extra copper right here, because it's purtier that way. So what we'll do to prevent fatigue is I'm just gonna make a loop in one of these, just like this. All right, so one wire is doing a loop, the other one's straight. And I'm not really gonna like crease down on the loop there. I'm just gonna kind of touch them together right here. And then I'm gonna slide my heat shrink over the entire loop, and my heat shrink's gonna tense it down. So what that's gonna do is it's gonna prevent any hard bending or fatiguing right at the splice or the crimp, which is where the wires always fail. The stranded copper out here is very tough. It's very resilient, it's flexible, it can bend a lot. So you can do a bend there. It's not going to cause a weak spot. And then the heat shrink is going to add even more backbone to this. So overall, the whole joint's going to have a little bit more structure to it, and it's not really going to be able to bend right here. It's going to be like a firm spot in the wire. So that's the joint that I've been using lately. Of course, ideally you want to go end to end from connector to connector, but we're not going to start depinning the fuse boxes on this thing. We're not going to tap into the body harness. That's way more than we're here to do. So anywhere that we have to mend 2 wires together end to end, this is the method we're going to use. It's going to look great, and it's going to last forever. Okay, so it's real late. It's like 11:30. We've been here
for a while.
7:30, 7:45 a.m. But we've been working on the car for the last 5 or 6 hours. So here's what we got done. We got all the wiring done, and just now connected to see if the Mega Squirt communicates.
And I would just like to say real quick, it doesn't look like we got a whole lot done when you look at the engine bay, because everything we got done is so clean.
There's one hideous thing I wish we would have cleaned up before this video. So we got all the Mega Squirt wiring. We'll probably tidy that up too with time. But all our modules are back there. The bulkhead connectors are kind of just up here up front where we could reach them. Probably try to tuck them back a little bit. But it's all wired in. Everything should be good to go. The harness we had to split this harness open to tap into some of those circuits, so we have to find a way to pretty that up, wrap it. It's pretty tight.
What time? We'll figure it out.
It's pretty taut, so we're gonna have to figure out how to like make that look a little better.
Taut like a tiger.
But not super worried about that, but finally got all the wiring done. I mean, really underestimated what tonight was going to entail, but it's all done, everything's here. So just cycled the key to ignition on, and the Mega Squirt does communicate. So I hooked right up. So I just wanted to look at some of our sensors, make sure everything's working here.
Yep, throttle position's good, all the way to 100, all the way down to 1.
Our wideband is not on right now.
I thought we knew that though.
The signal wire is not connected, but you still had hooked it up to power, and it's grounded. So we need to figure that out. The wideband's not on, which it should be. So I'm not sure what's going on with that. We'll have to look into that. That's kind of annoying, because Matt wired all that up and he put it back where it was, right?
Yeah, all the way back to the same.
So who knows what's going on with that? We need to look at that. It was working when we blew the motor up. This was our oil light indicator. It was only supposed to be on when we have oil pressure. That's why I ordered a green one.
Maybe we'll paint it red.
I would have ordered a red one if I would have known it was only on when there wasn't. But the diagram on all data showed that the switch was normally open and went to ground whenever there was oil pressure. So that's probably wrong. But anyway, so those two things are going on, which is kind of annoying. So we need to figure those out. But it communicates our intake, our coolant temp's showing 53. And it's 37 outside. So that seems plausible. Our pressure is showing basically 0. so that's good. Let's see, IAT. Actually, I think it's called MAT. Yeah, manifold air temp. And it's showing 70 degrees. Damn, that's pretty far off. What do you think the temperature is in here right now?
I would say like mid 50s.
Yeah, I was thinking maybe 60s at the highest. So we need to look at that.
Let's consult the fish.
Oh yeah.
Fish says, yeah, like 54.
Really?
Yeah.
Oh, so it's cold in here. Okay, so our intake air temp is reading incorrect. So this is all just tuning type stuff. But every sensor is giving a reading, so that's good. We still have to run our hoses to our map sensor, to our blow-off valve, fuel pressure regulator. So we'll save that for later. I just kind of would like to see it crank, or hear it crank. So you did everything right. We had to bypass the range switch, and we had to nab that circuit that goes to the starter.
Ooh, yeah. Just happy to see that baby turn again.
Yeah. Doesn't sound half bad either.
Man, that's great. I really like seeing those exposed cam gears spin around too. That's pretty cool. Yeah. You want to watch?
Yeah. Man, I was really hoping to hear it start tonight, but we still have to check for spark. We have to basically go through the whole rundown. Boy, those things sound like they're hitting. You heard it?
Yeah.
Go ignition on. Oh, cool. That was another thing we could check. Yep, fuel pump is working just like it should.
Yep,
Nice, dude.
So we did a lot of testing and stuff tonight and just determining to make sure we hooked everything right up the first time. And as far as we can tell, for the most part, seems like we did, which is good.
So now we need to find out why the wideband's not working, get the thermistors, the temperature sensors calibrated right. We need to make sure we have spark on the cylinders, set timing offset, make sure we have injector pulse. And once all of that is good, then we try to put fire to her. Yeah. So I'm up at the shop early. We got most of the wiring done, but just got to install all these little silicone hoses. I got the wideband sensor working, just a wiring issue there. So we're gonna get all the vacuum hoses installed and set the timing offset, and we'll be ready to start this thing up. All right, let's try to start this bitch. I just got it timed. I don't know what's gonna happen. Hold on.
It's gonna start. It's gonna start.
Battery's kind of weak. I'm just gonna start it on like this 10-degree base timing.
Yeah. Ooh. Oh. Oh, it sounds happy too.
Not all back popping.
I know. It started so easy. Yeah.
It's just purring like a kitten, dude.
Whoa, dude! It sounds so good and smooth.
Is anything dumping out of it? No. She's alive, baby! Yeah! Oh, man. That's what I'm talking about. Wow, it sounds so good, bro. Way better. Way better than anything. It sounded good before. Yay! It sounds a little deeper. It sounds way happier. Dude, so smooth. We did it! Oh boy, it sounds so happy. Hey, the oil pressure light's off too, which is just what we needed. Little green light is off. No lost sync. RPMs look good. Everything looks pretty happy. We're not gonna do too much before we get to like break it in a little bit, but nice, baby, yeah. I don't know if our alternator's gonna. The alternator's not working. We got to figure that out. Okay.
Okay, boy.